So today we are going to study about the jump instructions and range. So already we studied about the jump instructions. So again, this is our main concept. They are going to ask the range here. So that means they can ask later what are the different type of jump instruction range. If they ask, we need to explain about this topic. So already you know that here range is nothing but I can say here program counter means it is going to hold the address of the next memory, next instruction. So that means which is ready for execution. So at that moment, whenever in your program, whenever the jump instruction is appear, at that time it is going to add the new address in the program counter. So that is nothing but that previous address in the program counter is going to replace by the new one that is related to the jump. So once it is a new address is appear, at the time program execution is going to stop the present one, and again it is going to help for make the jump to the particular target address. So that means where it stopped the execution from that address and where it is going to make the jump that address. So for example, present stopped execution that address is something like the 0100H, and when the jump instruction is appear, at the time it makes the jump to the some other target. So that address is 0120H. So if you make the difference between these two, that means 0100 and minus 0120H. So the difference will be the 20H. So the 20H I can call it is the range of the jump instruction. Clear? So that means the difference between these two, I can say this is the range of the jump instruction. So herely there are three type of the jump instructions with that one they are going to call. So they are going to call it as the relative jump range, short absolute range, and the long absolute range. Or they can call it as the relative range, or short absolute range, and the long absolute range. So here we need to study one by one. So this is the jump instruction range. See the title here. This is the jump instruction range. So it is starting from the 00. That means 4 zeros up to the 4F. So again they written here a program counter minus 128D. D stand for decimal number plus 128D. So here they given some L jump. This is long jump, absolute jump, SJMP short jump, and these are already studied the JC, JNC, that is the jump carry, jump no carry, jump bit, and J and B, that stand for jump not bit, JBC, jump bit with carry. So like that already we covered this one. So here we need to understand here. First one is the relative jump or relative range here. So relative range is nothing but you need to see here, this is a relative limit, this one is the relative limit up to this relative limit. So range is given by minus 128 up to the plus 127. So that means you need to understand this is where the middle is a program counter. So that means if you are making this is a 00, that means it is like something like the increment order. This way of setup is the increment order. So that means when the program counter is somewhere in the middle, so this is your program counter. So that means when it is want to make the jump to the beyond the ahead of this program counter, at the time range it will be the plus 128 decimal. So higher it will be the plus 128. I can say this is a forward jump. Range will be the 127D. So again what will happen if it is somewhat like the jump, if you are making the jump to the program counter to the somewhat like behind some other target address, at that time that address range will be the minus 128 decimal. So that means overall I can say this range will be only minus 128 decimal to the plus 128 decimal. So here also it is the advantage of the relative range here. So only the 1 byte is needed to specify the data. 1 byte is nothing but I can say length of the instruction is very small. If it is the length of the instruction is very small, in the sense execution will be the high speed. So second thing you can observe here, Next one is the after the relative jump. Next one is the short absolute range. In the short absolute range is nothing but you can see here. Here he given the page number. Page number is nothing but 0, 1, 2, 3, 4, 5 A up to the 1F he given. So that means if you make the count this page number, that means the 1, 2, 3, 4. If you make it count, it will give the total of the. If you make the count here, this is total 32 pages are there. That means short absolute range is nothing but whatever the available memory address, that is a 404F. That entire memory address is divided into the logical divisions. So those logical divisions we are going to call it as the page. So that means they are divided into the 32 pages. So that means this is a page number. They divided into the total up to 1F means total 32 decimal. That is 32 pages they divided. Each page they are going to assign with the addresses. So that is nothing but the size of the one page is 2K byte. So it may be the anything. It may be the 256 byte or 4K or the 2K bytes also. There are so many etc. So, but in 8051, each page it is the going to provide the 2K size. 2K size is nothing but already I said 1K is nothing but 1024. 2K is nothing but 1024 into 2. That means 2048. So that in 2048 means we are start with the 00 address is nothing but that instead of 2048 it will come 2047. So that means. So here you can see here. So total here decimal. So already I said 2048. If you start with 00 means obviously it will be the 2047. So that means this decimal it is the 2047. So when you are going to convert it to hexa, it becomes the 7FF. So that means each page here, this is the 00, page number 0. Its range will be the 00 to the 7FF. 7FF is nothing but it is the 2K size. Similarly, after the next number 07FF, that next number will be the 0800. So that second one size also this is a 2K size. So that means this is entire. So that means this is also the 2K. So next page, that is the page number 1, that is also 2K, 2K, 2K. So like that 32 all the pages they divided with the size of the 2K here. So also they are provided with the different addresses here. So here this is a very easier to remember, don't make it by heart and all. So this is 4 zeros, this is 07FF, that is size 2K. Next one is 0800 and 0FFF. When you are writing the next address, you have to make increment here. Instead of 4 zeros, in increment by 1 means 1000. Again in place of 0, it becomes a 1. So 17FF. So next one is increment by 1. So 1800, 1FFF. So again next time 2. Increment instead of 1 here, write 2. And again this repeated, it is a repeated sequence. So up to the last year this one, F800 up to the 4FF. So that means in the short absolute range, it is given by the 16-bit address. 16-bit address is nothing but first 5-bit. So first 5-bit, it is going to tell about the page, which page you are going to consider. So that is nothing but most 5 bits is going to tell about the page number, and remaining the 11 bits is going to tell like that in that page what is the address. So in that page what is the address it is going to tell. So that nothing but it is the absolute range is nothing but it is a set of the 16-bit address. In that 16-bit address is a combination of the page number plus an address of the respective page number. So next one is the long absolute range. So long absolute range is nothing but it is going to assess the entire program ROM. That is size is 4 zeros to the 4F. So whatever this entire range will be there, this one we are going to call it as a long range here. So long range is nothing but it can access your entire the ROM address. So you can recall it once here. So this is the relative limit. So from here to here, 1 minus 128 to plus 127D. This is a relative address, relative range. So next one, after the relative range, this one is the absolute range. From here to here, this was absolute range. So this was last one is your the long range here. So apart from this one, again you need to recall one more here. So in the relative range, these all the jumps are, we can call it as the short jumps also. So these all the relative jump that is another conditional, or we are going to call it as a conditional and a non-conditional. So in jump already we discussed, conditional is nothing but based on the sum of the bit, that is a carry flag or it may be the particular bit, it is make the jump. That means if it is a carry here, it will make the jump here. Carry means already you know that C equal to 1. At the time if the carry is there, it will make jump. If there is no carry, also it is make the jump. That is nothing but based on the carry flag, it is make the jump here. This is a conditional jump. So this is also a CJNE. This is a compare jump not equal. So that is nothing but this is also it will make the compare. Next it will make the jump when it is non-equal. So that is meant what we can say here. These are the bit jump. Bit jump is nothing but based on the one bit, one value here, it make the jump here. Byte jump is nothing but it will perform like compare jump not equal, means first it will perform the comparison, next it will make the jump based on the some value here. So that means we can call it as these are the byte jump and these are the bit jumps. And we can say here these all the jump instruction, they are, we can call it as the short jump or we can call it as a relative jump here. So we seen the conditional jumps we seen, in that bit jumps are there and the byte level jumps are there. Next one is unconditional jumps also is there. Unconditional jump is nothing but that the L jump and the S jump is nothing but long jump, SJMP short jump, and one more is the AJMP. AJMP is nothing but this is the absolute jump. Last one is the NOP. NOP stands for no operation. So long jump is nothing but it will make the jump. This is a longer jump. So what we seen in the longer range, that is a 40 to 4F. So in that in between it helps to make the jump here. Short jump is nothing but we can say this is a relative range jump. So that is nothing but whatever you see in the relative range address, this is a minus 127 to plus 128. That in that range it helps to make the jump here. Absolute jump is nothing but we see in entire the memory address is going to divided by the logical divisions. That one we call it as the pages, number of pages. So that is nothing but by using the pages concept. So this jump is it make the that is nothing but number of pages means pages plus that address relative, that is total 16-bit address. So based on that it will helps to make the absolute jump. NOP is nothing but no operation. As the name indicates, no operation means it is simply it will make the software to waste the time. That is nothing but when sometimes you feel like that better to make waste the time 2 minutes or 3 minutes. If you decide you are not going to do anything, simply you will be idle. So like that here also, when you are using the NOP operation, it is not performing anything, but simply it will waste the timing for the software. So that is nothing but it is something like idle state. So it is the NOP, no operation. This is also a very important question in your exam. If they ask explain the jump instruction range, different type of the range is nothing but you need to explain about the relative jump, absolute jump, one more is the long range. So that means by using this diagram you need to speak about it. This is also a very important question. So again last one is the bit manipulation instruction. As the name indicates, bit manipulation is nothing but the particular bit manipulate means particular bit I need to make the alteration. So for that which instruction I can use? So already you know that 8051 is having the 128-bit addressable memory. It is having 128-bit addressable memory. In that bit addressable is nothing but it is a combination of SFR and some of the port pins. So if you want to perform the bitwise operation and the below the list of the instructions I need to use. So already we covered some classes here. This is a logical AND. So logical AND is nothing but this is the ANL, AND logic. So here we can use for the carry. If you want to make alteration for the carry flag and all, at the time we are going to use the ANLC comma bit. So that is a particular bit, which bit you want to make the AND operation. So here this is a logical AND, this is a ANL instruction. Logical OR is nothing but we need to write the ORL, OR logic. Clear bit is nothing but if you want to clear the carry flag or if you want to clear the some particular flag. CPL bit is nothing but this is a complement bit, complement C or complement bit. So that means if anybody asks what are the bit manipulation instruction is nothing but you need to tell this is a logical AND, logical OR and the CLR, clear bit and the complement bit. So whatever we discussed now, these all complete the instruction set. So this means you need to study this all arithmetic instructions, logical instructions and the branch instruction, that is nothing but jump instructions, and the bit manipulation instructions. So in the theoretical they can ask individually and explain it, or they can ask sometimes write the program with the small examples. So better to try to understand all the instruction and make it practice also.